This first example is a landowner, non-industrial private landowner that wants to improve habitat. And the idea here is it's not for any particular wildlife species. They just want to improve native Florida wildlife habitat in general. So this is really a habitat restoration objective. And this stand we're looking at is, something that's all over North Florida. It's a 200-acre compartment, a 15-year-old, relatively intensively managed slash pine. Has a site index base age 25 of 65 feet and 100 square feet of basal area. And this is a photo of what this compartment probably looks like. As you can see, it's not great general wildlife habitat, especially because of the understory situation. There's really no understory vegetation. So really what we'd be looking at here are prescriptions that take that current condition and apply treatments that really allow us to introduce prescribed fire and increase the understory vegetation, increase light to the understory, and allow us to establish a more diverse understory. So two scenarios we might look at are a thinning scenario where we apply a series of thinnings to greatly reduce the overstory basal area and then introduce prescribed fire. Those two things in combination will increase light to the understory. Prescribed fire will reduce that A horizon, that accumulation of needles, and allow establishment of understory vegetation from the seed bank and other seed sources for establishment of an understory community. So that's one potential approach. Another approach would be to make a series of group selection harvests. So basically small clear-cut harvests at 5-year intervals, and to plant longleaf pine in those openings and introduce frequent prescribed fire into those openings. So really, this is a conversion. So each of those group selection cuts is a regeneration cut, but with the planting of longleaf pine seedlings in those openings. So the idea here is over time to convert this stand into a multi-aged longleaf pine forest. And that frequent prescribed fire will benefit the longleaf pine and will also, in those openings, allow the development of an understory community. So what I've done here is run a growth and yield model, and with our site index and basal area for the existing stand, and run it out to age 25 with thinnings at age 15, 20, and 25. And this scenario, I asked it to thin 30% of trees at each of those thinnings. And what you can see is this shows us at that first thinning, which is basically immediately, we started out with 100 square feet of basal area, as I mentioned, and that removal of 30% of trees resulted in a residual basal area of 77 square feet per acre, with the production in that thinning of 4 tons per acre of chip and saw and 7 tons per acre of pulpwood. The second thinning at age 20, also removing 30% of trees, results in a residual basal area of 72 square feet per acre. And this amount of yield by product. And then the age 25 thinning similarly ended up with a residual basal area of 68 square feet per acre in this yield. So that's information on the products produced with each of those thinnings, and maybe just as importantly, the structure of the stand at the left. Well, that 30% removal resulted in, around 70 square feet of basal area per acre residual. And in my judgment, that is not an open enough canopy to allow the development of an understory community. So I said, okay, why don't I try a different scenario and have each of those thinnings remove 50% of the trees? Here's where I want to encourage you and remind you that growth and yield model runs and cash flow analysis runs are relatively easy and very fast. So don't hesitate to try different scenarios and play with different settings to achieve what you want to achieve. So, this is just an example. So here, with this higher, basically more intense thinning, removing more trees, at that age 15 thinning, we start with 100% or 100 square feet per acre of basal area and end with a residual basal area of 57. I'm a little bit more happy with that. Here's our products produced. At age 20, our thinning ends up with residual basal area of 42, and the age 25 thinning ends up with residual basal area of 36 square feet per acre. So why wouldn't we just go through and do a thinning down to this basal area at the first pass? Well, a thinning that intensive in a dense stand can result in lack of wind firmness in residual trees. So this sort of staged, gradual thinning allows the residual trees after each thinning to be stable and become wind firm. So if you're reducing basal area this much, it's usually best to do it in stages. This basal area that we're left with, I'm happy with. That's a very open stand. Only has 32 trees per acre, so that's a fairly open stand. So I'm going to stick with this as my thinning regime. Okay, so I've got that thinning regime from my growth and yield model. Now I'm going to use those data along with my prescription to cash flow analysis for that scenario. So I have a spreadsheet set up here, and this spreadsheet sort of is available to you on Canvas. The spreadsheet, I labeled my scenario. I'm using a discount rate of 5% because I'm a non-industrial corporate. I'm a non-industrial private landowner. Okay, so what I did was year zero, this is a 15-year-old stand, but remember, we're starting at year zero right now. That initial thin at year zero produced this amount of pulpwood and chip and saw. So what I did was take the prices from that revenue and cost sheet that we provided to you and calculated the per acre revenue produced by 10 tons of pulpwood and 10 tons of chip and saw. So that's basically 10 tons of pulpwood multiplied by the per ton price plus 10 tons of chip and saw multiplied by that chip and saw price. And that's $240 per acre. Okay, so this is revenue. And then this is my adjusted revenue column with that present value calculation in it. Because it's year zero, there's no adjustment to that value. I introduced fire. At this point, I think I waited a few years to allow the slash from the logging operation to decay a little bit. So I introduced prescribed fire at year 3. Cost $25 per acre. It's a cost, so I put it as a negative. And here's the adjusted cost of that, which, because this is in the future, that cost is adjusted to a smaller value. Okay. Here's the next thinning 5 years down the road, produced this amount of different products, and this is the revenue, and this is the time adjusted revenue. Again, fire 3 years after the previous fire, $25 an acre, and here's the time adjusted. So every 5 years we've got that prescribed fire treatment, And as you can see, as it gets further into the future, its adjusted cost is smaller because costs in the future are smaller in today's dollars. And then that final thinning produces this much tonnage in the different product classes, this much revenue per acre, and this is the time adjusted revenue per acre. Okay, so we sum those time adjusted revenues, sum those time adjusted costs for the entire series, and then subtract those. 645 minus 110 is 535. So that's $535 per acre net present value. The total, this is a 200 acre tract, so the total would be this number by 200, which would be $107,000. Okay, so that's our net present value for our thinning scenario. The group selection scenario is a little more complicated, and all of your scenarios won't be this complicated, but I wanted to demonstrate to you that you can think creatively in how to analyze these different scenarios. So I was thinking, okay, I've got a 200 acre tract, but I'm going to be making group selection cuts, which are basically little clear cuts in different parts of the stand, spread out throughout the stand periodically. And I'm going to be making those group selections at initially at 0 years, at 5 years, 10 years, and 15 years. So basically, I can use the growth and yield model to calculate what the yield would be for a clear cut at each of those times, now and 5, 10, 15, and so on years into the future. That allows me to calculate the revenue associated with those group selection cuts at different times in the future. Okay, so group selection cut now will produce 1 ton per acre of saw timber, 30 tons per acre of chip and saw, and 17 tons per acre of pulpwood for each of those group selections. 5 years into the future, 10 years in the future, 15 years in the future, that's what those group selection cuts will yield in per acre different products. Okay, so that allows me to calculate revenues for those group selection cuts. Okay, so here's the cash flow for that scenario. Now here, rather than doing it on a per acre basis, I'm doing it, I'm calculating revenues and costs based on how many acres of the total they're being applied to, because those acreages that I'm applying the harvests and the prescribed fire to are different over time. So, for instance, at year 0, I basically do a 20 acre group selection harvest, or actually 20 acres of group selection harvest, maybe in 5 acre blocks throughout the tract. So I have 20 acres of harvest. Here is my per acre yield associated with those group selection harvests. And this is the value of those products. This is per acre. So I multiply, for instance, the pulpwood price per ton by 17 tons by 20, because there's 20 acres, and do that for each of the product classes. So this is the total revenue for the tract for that 20 acres worth of group selection harvest. Okay. Similarly, so I'm going to go ahead and plant longleaf pine in that 20 acres worth of group selection. These are my planting costs associated with that 20 acres of burning, of planting, along with the cost to burn 20 acres. Okay. 3 years later, I go ahead and burn those 20 acres again, because I want to keep the prescribed fire going in those openings. And then after 5 years, I do another group selection. Okay, so at this point, this is the yield per acre of that group selection harvest. This is the total revenue for that additional 20 acres of harvest. I probably should have put a note here, 20 acres group selection harvest. This is the time adjusted revenue for that harvest. And then this is the cost associated with planting that 20 acres. You can see I went ahead and just waited until a burn to do that planting so that that prescribed fire would clear the site a little bit for the planting. So I waited till that sequence to do that. So this is the cost of planting that 20 acres of group selection, but now I'm burning 40 acres because I had that 20 acres that I cut initially and I've got another 20 acres. So I'm burning 40 acres. So this is that present value cost and the future value of that cost and the present value adjusted. I burned that 40 acres again after 3 years, and this is the future value and present value of those costs. Okay, here's another harvest, the revenue associated with another 20 acres of harvest, and the time adjusted value of that, and then the cost to plant those 20 acres. Okay, we burn again, but now we're burning 60 acres because we have 3 group selection harvests. Okay, that's repeated through that full 25 year period, so that by the end we've opened up 100 acres and planted longleaf pine across 100 acres of our 200 acre tract. So the net present value of that entire series, which is the net present value of revenues minus costs, is $123,000. So which option would you recommend? That thinning scenario had a net present value of $107,000. The group selection scenario had a net present value of $123,000. The net present value is higher for the group selection option, which economically is great. That's more efficient. I think I also like that option from just a broad habitat perspective because I've now I've converted half of my acreage of that compartment to longleaf pine with a range of age classes. So I've got a nice diverse set of age classes in that stand, higher present revenue. So I think that is the most efficient choice for me.